We are going to start now lecture 3 of chapter 9 class 11th mathematics sequence and series. So in this lecture we will talk about the sum of the n terms of an AP. So the first result we have is that if an AP is given whose first term it is A, last term is L, common difference is D and number of terms it is N, then we are saying that the formula for the sum of n terms it is n by 2 into A plus L, or we are saying it is equal to n by 2 into 2A plus n minus 1 D. So we are going to prove these results, that these are the sum of the first n terms. So if we write the sum Sn, we are saying the first term we have it is A, next term we will have it is A plus D, so on up to it is L minus 2D, then plus L minus D and plus L. Now this series we can write it again in this form, that it is L plus L minus D plus L minus 2D, so on up to A plus 2D, then plus A plus D and last term it is A. Now if we add both these values, if we add both these equations, we obtain the answer as 2 times Sn is equal to, first term will become A plus L, these two are added. When these two will be added, we will again get it is A plus L. Next, when these two terms will be added, so on up to plus A plus L, plus these two terms are added, we will get A plus L. These two terms are added, we will get it is A plus L. So the number of times this term is there, it is n times these are being added. So we get 2 times Sn is equal to A plus L into n. So the value of Sn we obtain it is n by 2 into A plus L. So this is the sum of a AP. Now if we substitute the value of L over here, last term we are saying, so that will be n by 2 into A plus n minus 1 D. So that will be equal to n by 2 into 2A plus n minus 1 D. So these are the two formulas that we have proved, that if an AP is given with n terms, then the sum of those n terms we can find by using any one of these two formulas. Next is, this question is there, it is find the sum of 23 terms of the AP, it is 5, 9, 13, 17. Now if we look at the common difference over here, it is 9 minus 5 is equal to 4. This is the value of D, this is the value of A that we have. The how many terms are there for which we want to calculate the sum? We want to calculate the value of S23, and the formula we have it is n by 2 into 2A plus n minus 1 D. So we obtain this is equal to, n by 2 means it is 23 by 2 into 2 into 5 plus 23 minus 1 into the value of D we have it is 4. So the answer we get it is 23 by 2 into, when you solve this value you will get it is 98. So it is equal to 1127. So this is the sum of 23 terms of this AP. Next is the first, second and last term of AP are A, B, C respectively. We have to prove that the sum of this AP it is this. So what is being given to us is that the AP we have it is A, B, so on up to C. So the common difference we have over here, it is B minus A, this is equal to D, common difference. So if we want to calculate that which term is this, we want to calculate the value of n over here. So we are saying, we are talking about C is equal to A plus n minus 1 into common difference we have it is B minus A. So the value we obtain it is n minus 1 is equal to C minus A over B minus A. So the value of n we have that is equal to 1 plus C minus A over B minus A. So this is equal to B minus we leave it in this way. Now we want to calculate the sum of this AP. So sum will be n by 2 into first term plus last term. So it will be 1 plus C minus A by B minus A upon 2 into A plus the last term, it is C. The last term is given to be C. And if we solve this value, we simplify this value, we obtain this is equal to B minus 2A plus C over B minus A into 2 into A plus C. And this is what we have to prove, that is the sum of this AP is equal to this value. Next is how many terms of the AP are needed to give the sum minus 25, and the second part we have is explain the double answer. So we are saying that this AP is given, the value of A we have it is minus 6, the value of D we have it is minus 11 by 2 minus 6, answer is minus 11 by 2 plus 6 is equal to 1 by 2, and the sum of n terms, suppose we are saying there are n terms, it is minus 25. So we are saying the value of minus 25 is equal to n by 2 into 2a plus n minus 1d. So what we obtain from this is that minus 25 is equal to n by 2 into 2a is minus 12 plus n minus 1, the value of d we have it is 1 by 2. So we obtain it is minus 50 is equal to n into, if we take the LCM over here, it is minus 24 plus n minus 1 by 2. So this value will become 100. So on solving this, we will obtain n square minus 25n plus 100 is equal to 0. It is quadratic equation in n, and its roots are n minus 5 into n minus 20 equal to 0. So this implies us n is equal to 5 or 20. Now why we are having these two answers? Because we are saying that the sequence we have it is minus 6, minus 11 by 2, minus 5, minus 9 by 2. Then we have some term A5, then we have A6, so on up to, then we have A19, A20, A21 and so on. Now if we are talking about these first 5 terms, their sum we are saying it is equal to minus 25. All these terms, these are negative. What will happen over here is that at some point between these terms, at some point the sign of the terms will change from negative to positive. We are saying the sum of these terms, it is minus 25. The terms in between this, their sum is basically 0. There are some positive terms, there are some negative terms, and the sum of terms in between these two terms, it is 0. And after this we are saying A20 we have over here, this A20 we are saying it is up to 20, it is not up to this term, it is up to 20, the sum is 0. So what we obtain is that the sum of all these values, we are saying the sum of values from A I is equal to 6 to 20 is equal to 0. That is, there are some positive term, there are some negative term, and their combined sum it is 0. So sum of all the terms from 1 to 20, that is also is equal to minus 25, and this is the reason for the double answer. Next is find the value of x when this value is equal to 148. So suppose we are saying this is the nth term. So we are having the value n by 2 into 2a, the value of a is 1, plus n minus 1, the value of d we have it is 5, that is equal to 148. Now if we solve this value, we will obtain it is n by 2 into, this is 2 plus 5n minus 5 is equal to 148. We get, if we shift this 2 on this side, this value will become 296, and these two values, it is minus 3 over here. So what we are getting is that 5n square minus 3n minus 296 is equal to 0. So this implies us n minus 8 into 5n plus 37 is equal to 0. So we get n is equal to 8 or n is equal to minus 37 by 5. Value of n cannot be negative. So we are getting that for n is equal to 8. We have, and this sum is equal to 148. It means we have to calculate, we want to calculate the value of x. So x we are saying it is t 8, and the value of t8 we have it is a plus 8 minus 1 d. The value of d we have it is 5, so we get it is 1 plus 35, so it is equal to 36. So this is the required value of x in this case. Next is find the sum of all odd integers from 1 to 1001. So we are saying we have 1, 3, 5, 7, so on up to 999, then 1001. Now in this case, we have the value of a is equal to 1, the value of d we have it is 2, the value of l we have it is 1001. Now if we are saying that this is the last term, so we want to calculate that, suppose this is the nth term. So what we obtain is that 1001 is equal to a plus n minus 1 d. So we obtain from this that n minus 1 is equal to 500. So this implies us n is equal to 501. So this is 501th term. So the sum of these terms, that will be as n, will be given by n by 2 into a plus l. So this is equal to 501 by 2 into 1 plus 1001. So the answer we obtained is 501 into 501, that is equal to 251001. So this is the sum of the odd integers from 1 to 1001. Next is find the sum of all natural numbers lying between 100 and 1000 which are multiple of 5. So if we are talking about the numbers lying between these two, so the first number we have it is 105, it is between these two numbers. Next will be 110, so on up to the last number we have it is 995. This is the value of L, this is the value of A, and the common difference D we have it is equal to 5. So we obtain that 995, that is equal to 105 plus n minus 1 into 5. So on solving this we will obtain the value of n, it is n minus 1 into 5, that is equal to 890. This implies us n minus 1 is equal to 178. This implies us n is equal to 179. This is the value of n that we have. Now we want to calculate the sum. So value of Sn is equal to n by 2 into a plus l, that is 179 by 2 into 105 plus 995. The answer we obtained is 179 by 2 into 1100, that is 179 into 550. So that is equal to 98450. So we are saying this is the required sum of all natural numbers lying between 100 and 1000. Next is find the sum of integers from 1 to 100 which are divisible by 2 or 5. So if we are talking about the numbers divisible by 2 or 5 is there, it is not 2 and 5, it is 2 or 5. So it is the first number, it is 2, next it is 4, next we are saying it is 6. These are the numbers that are divisible by 2, we are saying up to 100. Then we are saying the numbers which are divisible by 5, so they are 5, 10, 15, so on up to 100. Then we have the numbers which are divisible by both 2 and 5, so they are 10, 20, so on up to 100. So if we find the sum of these digits, if we calculate the sum of these digits, how many numbers are there? 50 numbers are there, so it is n by 2 plus 2 plus 100. How many numbers are these numbers? It is 20 numbers are there. 20 by 2, it is divisible by 5. So we are saying there are total 20 numbers are there. So n by 2 into first term plus last term. How many numbers are divisible by 10? It is 100 by 10 is equal to 10. So we are saying it is 10 by 2 into 10 plus 100. So in this case we have 2550. In this case we have 1050, and in this case it is 550. So what we are saying, we are talking about the numbers from 2 to 100 plus numbers divisible by 2 plus numbers divisible by 10 minus the numbers which are divisible by 5 and minus the number which are divisible by both 2 and 5, because these are counted already twice. We are saying we have the number over here 8, 10. This 10 is being counted over here. This 10 is being counted over here. So it is being counted twice. So we are subtracting this value over here, this 10 over here. So the final answer we obtain, it is sum of these two minus the numbers divisible by 10. And on solving this, the final answer we obtain, it is 3050. So this is the required sum. Next is find the sum of all 2-digit numbers which when divided by 4 yield 1 as a remainder. So these numbers we are saying which when divided by 4 yield 1 as a remainder. So the first number we have 2-digit number, it is 13. 13 when divided by 4 it yields 1 as the remainder. Next number we have, it is 17, then 21 and so on up to plus 97. The common difference we will have over here, it is 4. The first term we have over here, it is 13. So the number of terms, if we are saying the number of terms that we will have, it is 97 is equal to 13 plus n minus 1 d is 4. So we will get n minus 1 into 4, that is equal to 84. So the value of n minus 1 we have, that is equal to 21. So this implies us n is equal to 22. Now we want to calculate the value of Sn. So it is 22 by 2 into first term is 13 and last term is 97. So answer we obtain, it is 11 into 110, that is equal to 1210. So this is the required sum that we have. Next is the sum of n terms of two arithmetic progressions are in the ratio of this. Find the ratio of their 12th terms. So suppose the two arithmetic progressions that we have, they have the first term a1, it has second as a2, common difference is d1, common difference is d2, and it is being given that the sum of first n terms we are saying. So sum of first n terms will be n by 2 into 2a1 plus n minus 1 d1 divided by n by 2 into 2a2 plus n minus 1 into d2, and this ratio is given to be equal to 3n plus 8 divided by 7n plus 15. So if this n by 2 gets cancelled, so what we are left with is that 2a1 plus n minus 1 d1 divided by 2a2 plus n minus 1 d2, that is equal to 3n plus 8 divided by 7n plus 15. Now we are talking about what we have to calculate is the 12th term of first AP, that will be a1 plus n minus 1 d1. 12th term of second AP, it is a2 plus 11 d2. We have to calculate this ratio. So we are saying that we can write this is equal to 2a1 plus 22 d1 divided by 2a2 plus 22 d2. So what we obtain if we compare both these values, we obtain if we substitute the value of n is equal to 23 in this formula, we will obtain the value of this term. So if we substitute n is equal to 23 over here, what we will get is 2a1 plus 22 d1 by 2a2 plus 22d2, that is equal to 3 into 23 plus 8 divided by 7 into 23 plus 15, that is equal to 77 by 176, and that is equal to 7 by 16. So this is the required ratio over here. This is the required ratio of the 12th terms. Next is, in an AP, the first term is 2. The sum of first 5 terms is 1/4 of the sum of the next 5 terms. It is being given that the value of A is equal to 2. The sum of first 5 terms, that is A1 plus A2 plus A3 plus A4 plus A5, that is we are talking about S5, is 1/4 the sum of the next 5 terms. The sum of the next 5 terms means we are talking about A6 plus A7 plus A8 plus A9 plus A10. We are saying this value, it is A10. What this complete sum is? This complete sum is S10. If we are writing S10 minus S5, so this gives us the value or the sum of these 5 terms. And it is being given that S5 is equal to 1 by 4 times S10 minus S5. So if we solve this value, we obtain it is 5 times S5 is equal to S10. Now if we substitute the values of in this formula, it is 5 into 5 by 2 into the first term, it is 2 into 2 plus 5 minus 1d, that is equal to 10 by 2 into 5 into it is 2a plus n minus 1d. Now on solving this, we will obtain the value of d is equal to minus 6. We obtain the value of d is equal to minus 6. So now what we have is the value of a is 2 and the value of d is minus 6. Now we have to calculate the sum of the first 20 terms and this 20th term we have to calculate. So when we are saying 20th term, we are calculating T20. So the value of T20 we have, it is a plus n minus 1 into d. So that is equal to minus 112. This is the first part. Now we have to calculate S20. So that will be equal to 20 by 2 into 2 into 2 plus 20 minus 1 into minus 6. So the value we obtain, it is minus 1100. So these are the answers that we obtain, and these are the values that we have to prove, that the 20th term is minus 112 and the sum of the first 20 terms is minus 1100. So these are the answers in this case. Next is the difference between any two consecutive interior angles of a polygon is 5 degree. If the smallest angle is 120 degree, find the number of sides of this polygon. So suppose we are saying that this polygon has, the number of sides this polygon has, it is n, and the sum of the interior angles we know it is 2n minus 4 into 90 degree. Now in this question it is given that the difference between any two consecutive interior angles of the polygon is 5 degree. It means it forms an AP with common difference. The value of d is 5 degree and the smallest angle is this, it means the value of a is 120 degree. So if we have to write the value of Sn, it is n minus 2 into 180 degree. This value we are saying the sum of these angles. So if we write the value over here, we will get it is n by 2 into 2 into 120 plus n minus 1 into 5, that is equal to n minus 2 into 180 degree. On solving this, we will obtain it is n minus 2 into 360, that is equal to n into 240 plus 5n minus 5. So this, on solving this, we obtain, this implies us n square minus 25n plus 144 is equal to 0. This implies us n minus 9 into n minus 16 is equal to 0. So this gives us n is equal to 9 or n is equal to 16. Now if we substitute these values of n over here, we obtain, for the value of n is equal to 16, the last angle we obtain, it is 120 plus 16 minus 1 into d. So answer we obtain, it is 195 degree, and this thing is not possible for a polygon. So we are saying that the only possibility that we are left with is that n is equal to 9. So the answer in this case, we are saying that we obtain n is equal to 9. The number of sides of the polygon we have, it is equal to 9. Next is, the income of a man is rupees 4 lakh in the first year, and he receives an increase of rupees 10,000 in his income per year for 19 years. What is the total amount he receives in 20 years? So it is being given that A is equal to 4 lakhs. The value of D we have, it is equal to 10,000, and number of years we have, it is equal to 20. So we are saying what we want to calculate is S20. So that is equal to n by 2 into 2a plus n minus 1 is, this is the value of n, so it is 19 into 10,000. So on solving this, we will obtain, this is 10. This value will become 8 lakh. This value will become 190,000. So on adding these values, the answer we obtain, it is 990,000. So we are saying that he will receive a total amount of 99 lakhs after 20 years. Next we have is, a man saved rupees 6,60,000 in 20 years. It means the sum he has saved in 20 years, it is 6,60,000. In each succeeding year after the first year, he saved rupees 2,000 more than what he saved in the previous year. So suppose in the first year he saved A, next year he saved A plus 2,000, and likewise he continued. So the first term we are saying it is A, and the common difference over here, it is 2,000. The value of D we have, it is 2,000. How much did he save in the first year? So if we write the formula over here, it is S20 is equal to n by 2 into 2a plus n minus 1d. So substituting the values over here, we obtain 6,60,000, that is equal to 20 by 2 into 2a plus n minus 1 is 19 into the value of D we have, it is 2,000. So on solving this, we will obtain, and this value, it is 10 over here, so this gets cancelled. So we are left with this, that 66000, that is equal to 2a plus 380000. So this implies us this value we will have this much. So the value of 2a we obtain, that is equal to 28,000. So this implies us the value of A we have, it is 14,000. So this is the amount he has saved in the first year. Next is, in a potato race, 20 potatoes are placed in a line at an interval of 4 meters, with the first potato 24 meters from the starting point. So this is the starting point that we have. Then at a distance of 24 meters, the first potato is being placed, and then 20 potatoes are placed at an interval of, this is next, this is next, this is next, likewise some 20 potatoes are placed, and the distance between them it is 4 meters. A contestant is required to bring the potatoes back to the starting place one at a time. So what one has to do, he will start from this place, he will go up to this, he will bring back this potato. Then he will start from this place, he will go up to this and bring back this potato. Then he will bring back the third potato. How far would he run to bring back all the potatoes? So we are saying, to bring back this first potato, he will have to run 2 into 24, that is equal to 48 meters. To bring back this second potato, he will have to run 56 meters. To bring back this third potato, he will have to run 64 meters. To bring back the next potato, he will have to run 72 meters, and likewise we have 20 terms. So we are saying the common difference we obtain from this, the common difference in this case that we obtain, it is 56 minus 48, that is equal to 8 meters. The number of this is D, the value of A we have it is 48, and the value of N we have it is, there are total 20 terms. So the value, the total distance traveled, total distance, that is sum of all these values, this is N by 2 into 2A plus N minus 1 into D. So the answer we obtain it is 10 into 96 plus 152. So that is equal to 2480 meters. So we are saying that the total distance covered is 2480 meters. Now next we have is, in a cricket tournament, 16 school teams participated. A sum of rupees 16,000 is to be awarded among themselves as prize money. If the team in the last place is awarded 550 in prize money, and the award increases by same amount for successive finishing places, how much amount will the team in the first place will receive? So what we are saying, it is A1, A2, so on up to the last term it is 550. The common difference, suppose it is D, and the sum of all these values it is given to be 16000. So what we obtain is that this value is equal to, how many teams are there? There are total, N is equal to 16 teams. So we are saying it is 16 by 2 into 2A plus 15 N minus 1D. So on solving this thing implies us that 2A plus 15D, that is equal to, the 16 gets cancelled, and the answer we obtain, that is equal to 2000. This is one equation. And as this 16th term, it is T16 is given to be 550, so that is equal to A plus 15D. So we have two equations, one is A plus 15D is equal to 550, and second is 2A plus 15D is equal to 2000. Now if we subtract these equations, we will obtain A is equal to, it is minus A is equal to minus of 1450. So we are saying that the value of A1 we have, it is 1450. So that is the team in the first place, it will receive rupees 1450. Next is, the first term of an AP is A. The sum of the first P terms is 0. We have to show that the sum of the next Q terms is this. So we are talking about the first term of AP, it is A. The next term it is A plus D. Next it is A plus 2D, so on up to. We are saying the sum of first P terms is 0. there will be a term over here p minus 1 d. Next it is a plus p d. Next is a plus p plus 1 d, and so on. So we are saying the sum of these first p terms, it is given to be 0. So if we apply the formula over here, we are saying that Sp is equal to 0, that is equal to p by 2 into 2a plus p minus 1d. So this implies us that 2a is equal to minus of p minus 1d. So this implies us that d is equal to minus 2a over p minus 1. Now we have to calculate the sum of the next q terms. So we are talking about the sum of p plus q terms, that will be equal to p plus q by 2 into 2a plus p plus q minus 1 into minus 2a by p minus 1. Now the sum of first p terms, it is 0. So sum of this p plus q terms, that will be equal to sum of the next q terms, and this value is equal to, if we simplify these terms, it is p plus q by 2 into, we write 2a common from this, we are left with this 1. We have minus sign over here, it is p plus q minus 1 over p minus 1. Now on taking the LCM over here, we will obtain it is p minus 1 minus p minus q plus 1 over p minus 1. So what we obtain from this is, the value we obtain it is, this 1 and 1 get cancelled. So we are left with this, this 2 and 2 gets cancelled. We are left with this minus a into p plus q into q divided by p minus 1, and this is what we have to prove. Next is, if the mth term of an AP is a and the nth term is b, it is given that a is equal to, it is a is given, so we write the first term, say it is t. So it is t plus m minus 1 d, it is a, and the nth term is given to be b. So we are saying it is b is equal to t plus n minus 1 d. Show that the sum of its m plus n terms is this. Now what we have to calculate is, we have to calculate the sum of m plus n terms. So from these two terms, if we subtract these two equations, we will get a minus b, that is equal to m minus n into d. So this implies us that the value of d is a minus b over m minus n. Next, if we add both these equations, we will get a plus b is equal to 2t plus, when we are adding these equations, we will get it is m minus 1 plus n minus 1 d. Now we have to calculate the value of the sum of the m plus n terms. So the formula we will have over here, sum of m plus n terms, that will be m plus n by 2 into 2a plus m plus n minus 1 d. Now look at this equation over here, we are talking about this part of the equation. What we have is, it is 2t over here, we are saying 2t plus m plus n minus 1 d plus d, that is equal to a plus b. It means that in place of this term 2t plus m plus n minus 1 d, we can substitute the value a plus b minus d. So we are saying the sum we obtain, it is m plus n by 2 into a plus b, it is a plus b over here, minus the value of d we have, it is a minus b over m minus n, and this is what we have to prove. Next is, if the ratio of the sum of m and n terms of an AP is m square by n square. So we are saying that m square by n square is equal to m by 2 into 2a plus m minus 1 d. divided by n by 2 into 2a plus n minus 1d. We have to prove that the ratio of the mth and nth term it is this. It means we are saying we have to calculate the value of a plus m minus 1d divided by a plus n minus 1d. This thing we have to calculate. So if we look at this result, this 2 gets cancelled, this m get cancelled over here, this n get cancelled over here, and what we have is that m by n is equal to 2a plus m minus 1d divided by 2a plus n minus 1d. So this implies us that 2am plus mnd minus md, that is equal to 2an plus mnd minus nd. These two terms gets cancelled, and from this implies us that m into, we take m common from these two terms, we are left with is 2a minus d, that is equal to, we take n common, we are left with is 2a minus d. Now we have that m is not equal to n. We are saying that we have this m is not equal to n. So this implies us, from this equation we are saying this m is not equal to n, because these are the m and nth term we are saying. So what we will have from this equation, it is that 2a minus d should be 0. So this implies us that the value of d is equal to 2 times a. Now we substitute this value over here, it is 2 times a over here, 2 times a over here. This a gets cancelled. What we are left with is 1 plus 2m minus 1 over 1 plus 2n minus 2. So that is equal to 2m minus 1 over 2n minus 1, and this is the required ratio. Next is, if the sum of first n terms of a progression is quadratic expression in n, we have to show that it is an AP. So quadratic expression in n means we are saying that the value of Sn, it is given to be an square plus bn plus c. Now if we want to write the value of the general term over here, Tn, we are saying, I am explaining it over here, S1 we have it is a plus b plus c, that is sum of one term, and that is equal to the term 1. We are saying S2, that will be equal to sum of two terms, that is T1 plus T2. So that is equal to 4a plus 2b plus c. So if we want to calculate the value of T2, we are saying that is equal to S2 minus S1. Similarly, if we want to calculate the value of T3, it is S3 minus S2. S3 is T1 plus T2 plus T3, and we are subtracting T1 plus T2. So we are getting the answer as T3. So continuing in this way, we are saying that the nth term, that will be given by Sn minus 1. So we are saying that Tn, that is equal to an square plus bn plus c minus a into n minus 1 square plus b into n minus 1 plus c. We are subtracting these two values. So on subtracting these two values, if we solve these, we will get the final answer in the form 2an plus b minus a. We are obtaining that Tn is equal to 2an plus b minus a, and this is a linear expression in n. And we have already proved that if the general term is linear expression in n, then that progression, it is an arithmetic progression. Or we can find from this that the common ratio the common difference we have, it is a fixed common difference d is there. So we are getting that this is an AP. Next is, if there are 2n plus 1 terms in an AP, prove that the sum of odd terms and the sum of even terms bear the ratio n plus 1 is to n. So the number of terms we have, it is odd terms are there. So suppose we are writing the sum of odd terms, it is S1 we are writing, it is T1 plus T3, we are writing it is SO, so on up to plus T2n plus 1, and the sum of even terms we are writing SE, that is equal to T2 plus T4, so on up to plus T2n. We are saying this value is equal to n by 2, the number of terms, there are 2n plus 1 terms in the AP. So how many even terms will be there? It is n by 2 terms are there. The first term is T2 and the last term we have, it is T2n. And for odd terms we have number of odd terms, it is n plus 1 by 2 into first term is T1 and last term is T2n plus 1. Now we want to calculate their ratio. So we are talking about the value S1 or S odd over S even. So that is n plus 1 by 2 into T1 plus T2n plus 1 divided by n by 2 into T2 plus T2n. So the answers we obtain in this case, it is equal to n plus 1 by n into, what is T1? It is a plus 2n minus 1 d divided by T2 is a plus d plus a plus 2n, this is 2n d and this is 2n minus 1 d. So what we obtain from this, the numerator, look at this numerator part, this numerator is 2a plus 2n d, this denominator we have, it is 2a plus 2n d, both these terms gets cancelled and what we are left with is ratio is n plus 1 over n, and this is what we have to prove. Next is, if the mth term is 1 by n, it means 1 by n is equal to a plus m minus 1 d, 1 by m is equal to a plus n minus 1 d. We have to show that the sum of mn terms, we have to show that Smn, that is equal to mn by 2 into 2a plus mn minus 1 d, it is equal to 1 by 2 into mn plus 1. So if we subtract these two equations, we will obtain 1 by n minus 1 by m, that is equal to m minus n into d. So this implies us that the value of d is 1 by m into n. And if we substitute this value, suppose in the first equation, we will obtain 1 by n is equal to a plus m minus 1 by mn. We obtain a is equal to 1 by n into 1 minus m minus 1 by m. This is equal to 1 by n into m minus m plus 1 by m. So it is also is equal to 1 by m n. If we substitute these values of a and d, we have obtained the value of a is equal to d is equal to 1 by mn, and we substitute these values in this formula, we will obtain s of mn is equal to mn by 2 into 2 by mn plus mn minus 1 into 1 by mn. This mn and mn gets cancelled. We are left with this 1 by 2 into 2 plus mn minus 1. So the answer we obtain, it is mn plus 1 by 2, and this is what we have to prove, that the sum of mn terms is 1 by 2 into mn plus 1. Now next we have is, if the sum of the first p terms of an AP is same as the sum of first q terms, then we have to show that the sum of first p plus q terms is 0. So we are saying sum of first p terms, it is p by 2 into 2a plus p minus 1 d, that is equal to q by 2 into 2a plus q minus 1 d, and the value we want to calculate, it is sum of p plus q terms, that is p plus q by 2 into 2a plus p plus q minus 1 d. So if we solve this equation, we obtain this 2 gets cancelled, we get 2ap plus p into p minus 1 into d, that is equal to 2aq plus q into q minus 1 into d. So this becomes 2a into p minus q, that is equal to d into q minus 1 minus p into p minus 1. So if we look at this term, this will become q square minus p square minus q plus p. We can write it as q minus p into q plus p minus 1. Now clearly we have p is not equal to q, p and q, these are not equal. So these two terms p minus q gets cancelled. So what we get is that 2a, and this value if we look at over here, we have it is minus 1 plus minus 1, because this is p minus q, this is q minus p, d into p plus q minus 1, we obtain it is equal to 0. Now if we substitute this value obtained from this in this equation, we get the answer is equal to 0. So what we are saying is that the sum of first p plus q terms is 0. Next is, if the sum of m terms of an AP is n and the sum of first n terms is m, we have to show that the sum of its m plus n terms is minus of m plus n. So it is given that n is equal to m by 2 into 2a plus m minus 1d, and m is equal to n by 2 into 2a plus n minus 1d. Now if we subtract both these equations, we will obtain n minus m, that is equal to 2a by 2 into m minus n plus d into m minus 1 by 2 minus n into n minus 1 by 2. So from this equation, we are getting n minus m is equal to 2a m minus n by 2 plus d into, if we look at this term, we are writing 2 common. What we are left with is m square minus m minus n square plus n. So from this term we can write it is m minus n into m plus n minus 1. So we are writing it is m minus n into m plus n minus 1. Now this m minus n get cancelled, we are left with minus 1 over here. So what we obtain from this is that minus 2 is equal to 2a plus d into m plus n minus 1. Now we want to calculate the sum of m plus n terms. So sum of m plus n terms is m plus n by 2 into 2a plus m plus n minus 1d, and the value of this term 2a plus d into m plus n minus 1, it is minus 2. So we are getting it is m plus n by 2 into minus 2. So answer we get it is minus of m plus n. So this is the sum of m plus n terms that we have. Next is the sum of the first p, q, r terms of an AP are A, B, C respectively. We have to prove this result. So what is given to us is that A is equal to, suppose the first term we are saying it is x. So A is equal to p by 2 into 2x plus p minus 1 d. So from this equation we will obtain that A by p is equal to x plus p minus 1 d by 2. Similarly, b by q, that is equal to x plus q minus 1 d by 2, and r c by r, that is equal to x plus r minus 1 d by 2. Now we want to calculate the value of these terms. So if we multiply these equations with q minus r, r minus p and p minus q respectively and add them, we will obtain this side. We are saying we will obtain a by p into q minus r plus b by q into r minus p plus c by r into p minus q, that is equal to, it is x is common, we are left with this q minus r plus r minus p plus p minus q, and then it is plus d by 2 common. We have p minus 1 into q minus r plus q minus 1 into r minus p and plus r minus 1 into p minus q. Now clearly this q gets cancelled, p gets cancelled, r gets cancelled, this term will become 0. If we look at this term, we are talking about this term over here, what we will have is pq minus pr minus q plus r. Next we have is qr minus pq, this is minus pq, and then it is minus r plus p, and from the last term we have it is rp minus rq, then it is minus p and it is plus q. Now again in these terms this q gets cancelled, r gets cancelled, all these terms gets cancelled, and the value of this term it will be 0. So we are saying that this whole value we have, it is equal to 0, and this is what we have to prove. Next is if the sum of the first n, 2n and 3n terms of a AP are S1, S2, S3, we have to prove this result. So the value of S1 we have it is n by 2 into 2a plus n minus 1d. The value of S2 we have it is n into 2a plus n minus 1d. It is 2n. And S3 we have it is 3n by 2 into 2a plus 3n minus 1 d. Now we are calculating 3 times S2 minus S1. So that is 3 into S2 is n into 2a plus 2n minus 1d, and it is minus n by 2 into 2a plus n minus 1 d. Now we can write it is 3n by 2, we are taking n by 2 common from this, we are multiplying and divide this term with 2. So what we are left with is 4a plus 2 into 2n minus 1d, then minus 2a minus n minus 1 d. So this term, it is 4a minus 2a, this will become 2a, we have 3n by 2 common, we are left with is 2a plus, we have these two terms, we are writing d common, and we have 4n minus 2 minus n plus 1. So we get it is 3n minus 1. So it is 3n minus 1 d, and this is the value of, this is equal to S3. So we have proved that 3 times S2 minus S1 is equal to S3. This is the This is what we have to prove. Next is, if S1, S2, S3, Sm be the first m terms of m arithmetic progressions whose first terms are 1, 2, 3, m respectively, and the common differences are 1, 3, 5, so on, then we have to show that S1 plus S2 plus S3 so on up to Sm is equal to this value. So we are talking about, we have m arithmetic progressions. First is 1, 2, 3 and so on. We are not writing the last term over here, some last term will be there. Second, we are saying it is starting with 2 and the common difference is 3. So it is 2, 5 and then it is 8 and so on. Likewise, third start with 3 and the common difference is 5. So it is 3, 8, 13 and so on. And this S1, S2, S3, these are the sum of the first n terms. So what we will have is that the value of S1 we have, that is equal to n by 2 into 2 into 1 plus n minus 1, d is 1. If we are talking about S2, it is n by 2 into 2 into 2 plus n minus 1 into 3. The common difference in this second, it is 3. S3 we have, it is n by 2 into 2 into 3 plus n minus 1 into 5. The common difference we have, it is 5. And continuing in this way, we have Sm, the mth one, last one we are saying, the last sequence we will have, its sum is n by 2, 2 into m plus n minus 1 into 2m minus 1. Now if we add all these values, we will obtain, it is S1 plus S2 so on up to Sm, that is equal to n by 2 into, we are adding these values, so it is 2 into 1 plus 2 so on up to m plus n minus 1 into 1 plus 3 plus 5 so on up to 2m minus 1. Now this is equal to n by 2 into 2 into m plus 1 by 2 plus n minus 1 into, it is sum of the odd terms that we have, and the sum of these odd terms, it will be m by 2 into the value we will have, it is 1 plus 2m minus 1. The value we are saying, it is m plus 2m minus 1. So we are obtaining this expression over here. We are talking about this expression. We are having this value, and if we simplify these terms, the final answer we will obtain, it is in the form 1 by 2 m into n into mn plus 1. Now an important thing to note over here, that we are using this formula, these two formulas we are using, and these we will discuss in our next lecture. These formulas, these are in part of our next lecture. We are just using these formulas over here, but the proofs and details of these formulas, these will be discussed in our next lecture. Next we have is, if the sum of m terms of an AP is equal to sum of either of the next n terms or the sum of the next p terms, we have to prove this result. So we are saying that the sum of the m terms, that is equal to sum of next n terms, it is m plus n minus Sm. So we obtain 2 times Sm is equal to S of m plus n. So this implies us 2 into m by 2 into 2a plus m minus 1d, that is equal to m plus n by 2 into 2a plus m plus n minus 1d. Now if we simplify these terms, we will obtain, this get cancelled, it is 2m into 2a plus m minus 1d, that is equal to m plus n, we are writing this 2 over here, we are not writing it over here, into 2a plus m minus 1d plus n, it is nd. Now if we substitute this term as x, we will obtain it as mx is equal to m plus n by 2 into x plus nd. So this implies us that 2mx is equal to m plus n into x plus m plus n into nd, and this thing implies us, if we rearrange this term, that this 2mx minus mx minus nx, that is equal to m plus n into nd. So taking these two terms will give us, taking x common, we will get this is m minus n is equal to m plus n into nd. So this is the result for when we are saying it is sum is equal to the sum of next n terms. Now similarly we are solving for this value p, we will have x into m minus p, that is equal to m plus p into p into d. Now we have two equations, this is equation number 1 and this is equation number 2, and if we divide both these equations, we will obtain, if we divide both these equations, we will obtain that m minus n over m minus p, that is equal to m plus n into n divided by m plus p into p. Now if we cross multiply these terms, we are talking about this result over here. Now if you cross multiply these terms and simplify these terms, this calculation, this simplification, these are shown over here. If you simplify these terms, you will obtain the final answer in this form. So this thing you can try at your own, you can look at these calculations and you can try at your own that you are obtaining this answer on simplifying this value. Now next we have is, if the sum of n terms of an AP is Cn plus Dn square, where C and D are constants, then show that the common difference of AP is 2D. So the value of Sn is given to be Cn plus Dn square. Now if we are talking about the term n, it is given by Sn minus Sn minus 1. So that is equal to Cn plus Dn square minus C into n minus 1 plus D into n minus 1 square. So we are writing this is equal to Cn plus Dn square minus Cn minus C plus Dn square plus D minus 2Dn. So this is equal to Cn plus Dn square minus Cn plus C minus Dn square minus D plus 2Dn. So this Cn gets cancelled, Dn square and Dn square get cancelled, and we are left with this C minus D plus 2Dn. This is the nth term we are saying. Now the common difference is given by Tn minus 1. So that is equal to C minus D plus 2D into n minus C minus D plus 2D into n minus 1. So from these two terms, this C and D gets cancelled and we are left with this 2Dn minus 2Dn plus 2D. So that is equal to 2D. So we are saying the common difference between these two terms, between the terms of this AP, it is 2D, and this is what we have to prove.